how blockchain leverages DevOps principles. My name is JeanDaniel Bussy. I'm the CTO and co-founder of Stacktical. I'm a cloud architect on DevOps. Who in the audience is actually a DevOps? Just one? No way. Who is familiar with blockchain technologies? All right, cool. Don't hesitate to ask questions, and let's keep this very interactive. So who are we? We are Stacktical, a decentralized service level management platform. We really tackle DevOps problem using leveraging blockchain technology. We are the very first decentralized service level management platform that automatically indemnify customers for IT downtimes. I would like to give a big thank to DevOpsLinks, Mobiskill for providing the facilities, Crypto Times with Toshi Weekends came from Japan, and Eralas. Thank you guys. So what is blockchain? Blockchain is a distributed database. You have in the blockchain all the transactions and all the record of everyone's account maintained and verified by every single node of the network. So if you would compare blockchain like Bitcoin to a bank will have all the transactions and all the information about everyone's bank account inside their database. They are in control and they decide about the rules. With blockchain, every single node is distributed all over the world with no single point of failure. Nobody can really control the blockchain. And it's completely open source, transparent, and incorruptible. Compared to Bitcoin, you have Ethereum, which is another blockchain that adds a level of programmation. You can run an application on top of the blockchain. So the piece of applications that will run on the Ethereum network blockchain is called a smart contract. And the way this system works is that to execute a smart contract, you will have to pay some gas that is determined according to the complexity of the smart contract. So because a very complex smart contract will cost you money, this blockchain can somehow make sure nobody will run applications that are way too complex for him to be able to run. So with smart contracts, you can run ICOs, you can have simple applications, voting applications. You can have a certain level of programmability that allow you to cut and to add the trust advantages and the transparency that the blockchain provides. When you put smart contracts together with a backend and a frontend, well, you have a dApp. Maybe you guys are aware about CryptoKitties. Well, CryptoKitties is a full-fledged dApp. In the blockchain, you have several smart contracts. You have a backend and you have a front-end, your web UI. Yes?
What's the purpose of the backend here?
So it actually depends. You can have the front-end that interact directly with a smart contract, or you can have some logic on top of the blockchain. Just to give an example about gas. So when you write your application, your smart contract, you have to be very careful about the complexity. A simple multiplication or division will cost you 3 of gas, for example, but inquiring the balance of accounts will cost you 400 of gas. So when you write your smart contracts, you would avoid too much complex operations like a loop that have very heavy computation, because at every iteration of the loop, you will waste gas. So keeping these constraints in mind, we will see how DevOps principles apply to blockchain. We like to call the combination of blockchain and DevOps BlockOps. This is an experiment, we'll see how it goes. Maybe it will spread over the world. Let's see. So to answer this question, let's look at the DevOps lifecycle. The only one DevOps in the room must be familiar with this. There is another one. Of course, Ayman knows about it. This is a life cycle where teams decide about the plan, about the development of an application. Just a note about before DevOps, because, well, let's define DevOps a little bit. DevOps is a combination of developers and operation teams. Before, you had developers writing their code, shipping features as fast as they could, because that's how your manager will say, well, you push a lot of features, you're a good developer, right? So they will push new feature and they will give it to ops, who will make sure the thing run and scale. And you will, because all those teams will be really focused about their performance and their own task, they wouldn't really cooperate. DevOps really try to bring those developers and operation teams together to make sure that a service will scale and run in the best condition from scratch. When you plan with DevOps, you make sure that your architecture, your application is designed to run in the best condition. So after the teams decide about the feature and the plan about the service, you have the coding, then you build your application. Hopefully you build it in a way that it's repeatable, transportable, safe. And then you will enter into the continuous testing. With continuous testing, you will have, as you are hacking, as you are developing your application, you will run a series of tests that will check the quality and the performance of your application. Then you will have the release phase, where Q&A people will try the application into a Q&A environment. In the best case, in the best situation, you will have a Q&A environment that is exactly or really similar to the production environment. So you will test your application and make sure that the application behaves as it should be in production. Then you deploy, you operate, and you monitor. Monitor to check if, well, everything goes well, you gather customer feedback, and the loop starts again. This is a Holy Grail DevOps lifecycle. In this lifecycle, in this traditional lifecycle, you have several pain points. Actually, developers, they don't like to test. There is several developers who just write code and they test afterwards. Well, we will see that with in the blockchain world, this doesn't work actually. So we will see every section of the lifecycle, and we will see how it works with smart contract and blockchain development. So first, you plan something, you get an idea, you want to decentralize something. You will try to apply the benefits of blockchain to a pain. Most likely wherever you have trust issues, where you have a third parties that have to be involved in a process to bring trust. So with blockchain, you might be able to cut corners, save costs, and bring transparency. So after you get your idea, you plan, and you can start to code. To code smart contracts, you have a nice set of tools called the Truffle Suite. The most important piece is Ganache. Ganache is basically a one-click blockchain right into your computer. Before, you would want to code, you would want to develop a smart contract, you will have to maintain a node on the blockchain. And you will have to wait hours for it to synchronize with the network. With Ganache, you install it, you run it, and you can test with your localhost blockchain. Truffle is a dev framework, and Drizzle brings you all the front-end libraries that can help you to build a full-fledged dApp, because, well, a smart contract as itself doesn't have any sense, make any sense if you don't have a front-end. Yes?
A question about it. So what kind of blockchain it is? Is it a public blockchain or is it like...
So this is most likely on a blockchain where you can run applications like Ethereum or EOS.
Okay. So it's on public blockchain.
It's on public blockchain. But first, on this life cycle, you run on your local host. You test on your local host. We will see later how you get it deployed in production. And then you build. So with Truffle build, you can actually extend your build process and customize it to then have your continuous testing. Because smart contracts, when you push a smart contract on the blockchain, it's over. You cannot change anything anymore. You cannot replace it. You cannot stop it. It's there. So if you made a mistake, this mistake is going to be there. On this mistake, in the case of a smart contract that manages money, you can make sure people will try to hack it. So it's very important to try and to test your smart contract in every single way to make sure there is no bugs. So when you're continuous testing, when developing smart contract, you will run your truffle test, your unit test. You will make sure that your test coverage is 100%. You will run your linting and security analysis with a tool like Neutral OSS. But that's not enough. Like I said, people will constantly try to hack your smart contract. It's basically you taking the bet that your code is safer than all those people trying to attack your smart contract. So most likely you will want to have a second pair of eyes that will look into your code with different opinions, different skills, most likely an expert that will run a full security audit on your smart contract. You also have advanced testing, like formal smart contract verification. Formal smart contract verification actually explore every, every single possibility of your compiled application, and we explore it to find bugs. So this way you can make sure that your smart contract is 100% bug-free. But 100% bug-free smart contract doesn't mean it's not hackable. When you write a smart contract, you expect people to behave in a certain way. But actually people might be able to game your application, your smart contract, in a different way. So there is the testing incentive structure of smart contract, where you basically have AI that will try to game, that will try to any kind of weird combination against your smart contract to try to find security holes. What I wanted to say, I forgot. Yes?
The testing is done through Ganache, or is it your own tools?
You can run it your own tools, but most likely it will be a third party that will, because, well, if you have the hardware to be able to run this AI test, this stress test for actually last days or hours, you can do it. Otherwise, you can ask a third-party audit service, that will run this specific test for you. And actually ourselves, we are considering doing that our own smart contracts. Because, well, of course it's convenient. Just looking at every single line of code is not enough sometimes. It's just the fundamentals, and you be expecting people to behave in a certain way is not enough. And this is actually possible because smart contracts, by the incentives of keeping the smart contract logic very basic and the computation very low, this kind of test is possible. Yet still it lasts hours or days. And then there is a deploy phase, just like in the traditional centralized world with DevOps. You would have a staging environment that will mimic your production environment. So in Ethereum, you have the testnets. You have actually two testnets, and the main ones are Ropsten and Milkubai. They have a very little difference. For example, for Ropsten, you will be able to mine Ethereum with a very low difficulty. So with your own hardware, you can actually mine Ethereum and test those Ethereum with your smart contracts. For Milkubai, which is run by proof of authority, you will basically have to ask somebody to give you some Ethereum. And they will give it to you for free or for some incentives like tweeting or posting something about the Milkubai testnet. So when you done all your Q&A, all your testing, and all your validation on staging, the testnet, you can run it, you can then deploy your smart contract on the mainnet, the Ethereum network. And this is where you will have people who start to interact with your smart contract. In the case of an ICO, people will inject money, inject funds in your ICO. But then, how do you operate your smart contract? Well, most likely you won't operate a smart contract. Why? Because the fundamentals of a blockchain is to get rid of central of power and authority. You don't want to have an admin that is able to come with the private key and withdraw the funds or just go away with the money. So when your smart contract is developed, is published on the Ethereum blockchain, code is low. To take the example of the DAO attack, well, the DAO smart contracts was actually holding $150 million. And then people found a hole, they found a bug, and they managed to steal money from the smart contract. Well, this smart contract had no mechanism of defense, of self-preserving mechanism, because introducing such mechanism could be actually a bug. And that could be also a security issue where somebody would be able to use that security mechanism to steal the money. So when you deploy your smart contracts, you most likely won't have to operate it. It has to be safe by design. So you have very low governance, very rare updates. And if you have updates, you will need all the stakeholders to agree and to vote to apply and accept changes. Functions are very limited. You can most likely check the number of tokens in the smart contract, who is whitelisted or not, stuff like that. So that, yes?
You said earlier that once it's on the blockchain, you cannot delete any kind of smart contract.
Yeah.
But there you're saying that changes are possible once you have a forum, the community. But would that be able to have the community cooperate to delete a smart contract from the blockchain?
They wouldn't be able to delete at all. Maybe update it. You have Zeppelin OS that have some update mechanism to actually bring new securities to the libraries that you use. But you can also have your smart contract that is self-upgradable. In this case, you will want to have multiple people that will be able to multi-sig contract with, whereas a certain amount of administrators will be able to update a smart contract.
But there's no way to delete it.
There is no way to delete a smart contract. No. Once it's there forever. So actually, there is a good example of that, and that you have to be very mindful of how it's, everything put on the blockchain is inimmutable. There is a Twitter application called PPF that basically have all your tweets on the blockchain. And they warn you several times that you have to be careful about what you tweet, because once it's there forever. So for the monitor part, it's very primitive. You have my Ether wallet, where you can basically call some functions of your smart contract. Maybe I can show you an example of those tools. Yeah, so you have Etherscan, where you can view and execute some function of your smart contract if you have the primary key. There is Etherscope, where you can explore some smart contracts. Let's say, I don't know. So for this smart contract, you can see the number of tokens, how the number of tokens evolve over time for this smart contract. So you kind of have some kind of tools that can allow you to, yeah, it drops at some point, I don't know why. Yeah. So does the blockchain principles applies to blockchain? I would say mostly. Especially on continuous testing part. Of course, the fundamentals of Ethereum blockchains make you focus on different points. You have to be very careful about the testing phase. But well, DevOps principle does mostly apply to smart contracts. So yeah, thank you. If you got some idea, if you like the idea of BlockOps, you get just go away and decentralize something. Thank you for your attention.